So previously wasu sun yi magana cewa mu yi masu yadda ake solving quadratic equation using completing square method. So in a general form, idan aka ce quadratic equation shine equation wanda yake a form of ax square plus bx plus c, which is equals to 0. So yanzu daga nan abinda za mu shine mu ɗauke c ta koma can because it is the only constant term na gare mu anan. So ɗauke ta koma can gefen because we have positive c here, so it is going to be negative c right there. So this will be transformed to 0 minus c because it is plus c mun ɗauke ta koma can. So let us rearrange it. Mu yi rearranging zai koma negative c. So daga nan sai mu dividing by the coefficient of x square shine divide by a because a is the coefficient of x square. Gaba ɗaya throughout divide through by a. So daga nan therefore we have this over a, bx over a, everything over a. Okay? Komi over a. This will go with this. So x square plus b over a x is equals to negative c over a. Daga nan, what we should do, make coefficient of x ana. Ba wai a coefficient of x square ba, coefficient of x, which is b over a. B over a is the coefficient of x. So let us find half of b over a. So sai mun gano half of coefficient of x. Therefore, in kana so gano half ɗin abu kawai zaka ce half 1 over 2 kenan times shi. So 1 times b is b, 2 times a is 2a. Wannan shi ne. So daga nan sai mu squaring ɗin half of coefficient of x because half of coefficient of x is now b over a, b over 2a. To square it, squared. Bayan mun yi squaring ɗin shi mu ɗauko wannan value ɗin mu adding ɗin shi to both sides. Mu adding ɗin shi to both sides. So add it to both sides. So therefore we have ax square plus b over a x. We have to add one term to this side. Square minus this plus b over 2a squared. Mun yi adding ɗin shi to kowane side. Gashi. So daga nan idan za mu factorizing wannan alone, kawai za mu ɗau x da wannan half of coefficient of x mu mashi square. Shi ne zai koma x plus b over 2a only square. And then we have minus c over a. B square is b square. 2 square 4. A square we have a square. So mun buɗe wannan bracket ɗin mun sa ma kowanne square ɗin shi. B mun sa mata zama b square, 2 mun sa mata zama 4. A mun sa mata zama a square. Daga nan we can move to the next step. That is x plus b all over 2a squared minus c over a plus. For example, before we reach this step, we can take LCM. LCM is 4a square. So we have 4a square. A here, 4a. 4a, because a in ta shiga nan za ta kashe wannan square ɗin ta bar 4a. So dole mu multiply by ta sama, which is negative 4ac. Because 4a times negative c is going to be negative 4ac. 4a square here, 1. 1 times b. 1 times b square is just b square. This is something as b square. If we try to rearrange, this is something as this. Because we are just rearranging. So daga nan we can take square root of both sides. So zai zama b all over 2a squared. Square. Whenever we take square root, dole mu sa plus or minus. So plus or minus b square minus 4ac over 2a mun ɗau square 4a square mun ɗau square root ne don mu kashe wannan square. So this one cancels this. Me ta rage? Only x plus b all over 2a only, which is equals to square root of a can sama b square minus 4ac all over, because square root of 4 will be 2, square root of a square will be a. See? Now we can now decide to take plus b over 2a to the other side. The mun ɗauke shi koma can ya zama negative. So what we have only here is x is equals to minus b all over 2a plus or minus, because that plus into koma can gefen ta zama minus square root of b square minus 4ac all over 2a. So now we have common denominator, 2a, so we can just take one of them and combine the numerators. So here come mu haɗa numerators ɗin na sama saboda a ƙasa duk muna da 2a, so mu ɗau guda ɗaya. So that is it. That's all. So whenever you are asked to solve an equation using completing square method, doesn't matter menene a sama, a square ne, ax square ne, why, this is a procedure. Divide through by a, after taking the constant to the other side, then find the half of coefficient of x, square it, add it to both sides, factorize the left hand side, expand, simplify the other side, take this half to the other side, negative, and then you will end up having your x minus b plus or minus b square minus 4ac over 2. This is general formula. We can solve any quadratic equation using this general formula. For example, idan aka bamu equation like this, x square plus maybe 2x plus maybe 3, which is 0. We are asked to solve this using general formula. In this case, b ɗinmu shine coefficient of x, a ɗinmu shine coefficient of x square, c ɗinmu ita ce constant always. So in this equation, our a coefficient of x square will be 1. So our a will be 1. Our b will be coefficient of x, which is 2. Our c will be the constant, which is 3. So daga nan we can apply the formula minus b plus or minus square root of b square minus 4ac all over 2a. So daga nan minus b, that means minus 2. So the b ɗinmu is 2 plus or minus square root of b square, that means 2 square, which is 4, minus 4. 4 times a, which is 1. 4 times 1 times c, which is 3, that means times 3. All over 2a, that means 2 times 1. So x ɗinmu will be minus 2 plus or minus a can ciki 4 times 1, 4 times 3, 12. 4 minus 12 is going to be negative 8. Negative 8 all over 2 times 1, 2. And then we have a square root of a negative number. So the answer is going to be a complex answer. So this one will be minus 2 plus or minus root of negative 8 is going to be 2 root 2i, because this is a complex number. So plus or minus 2 root 2i all over 2. So this is going to be 1. This is going to be cancelled. So plus the answer will be x is equals to minus 1 plus or minus root of 2i. In this case, because it is a complex number, we cannot find the square root of a negative number. So in case you have something which is solvable, so you can simply follow this method, and solve your problem and solve the quadratic equation. So that's all. I hope this is enough for you to understand how to solve completing square by completing square method, how to solve a quadratic equation by using completing square method, and by using the general formula, which is derived right here. Thank you.